All right, folks, welcome back. All right, I see that there's only two attendees, right? Maybe others are joining, but I guess we'll get started, right? Okay, so we are in the second week of this 5-week course, right? And we are in module 3 at the moment. I hope you guys have had a chance to practice, right? I know, Greg, you've been practicing, right? And by the way, we're working on your, the problem you reported. We are working on that, and we'll get back to you very soon. Hopefully, I'll cover that tomorrow. All right, so let's start with today's session, which is module 3, and the topic today is storage services. All right, so so far we've looked at one compute service, right? So as you know, there are many categories. There's compute and storage and networking, databases, management tools, etc. And what we've seen in the last week is EC2, which is part of the compute category of services, right? So today we look at some storage services. There's multiple services that we look at. EBS, which is Elastic Block Store. We look at S3, which is a simple storage service. We look at Glacier, which is a very low-cost mechanism for long-term archival, and a couple of enterprise or hybrid type of services as well, Storage Gateway and Snowball. Right. So the focus today is storage. So we'll be covering compute, storage. And then tomorrow we look at networking. Right? So especially within networking, we'll be looking at virtual private cloud. This is an important topic, but a little bit difficult. Right? So tomorrow this is going to be a little bit difficult because we're not familiar with networking topics as much as we are with, say, databases or application related stuff. Right? So this is the agenda for today and for tomorrow. All right, so just a quick look back. Last in module 2, right, we looked at EC2, especially armies, right, Amazon Machine Images. These are basically templates using which you can create your EC2 instances. You can have any sort of OS, Linux, different distributions within Linux, Windows servers. You can also have commercial products, open source products in those armies, and of course you can also create your own armies, right? So armies are central to EC2 instances. Armies is the first step, right? It's the first step that you have in creating your EC2 instances. We also looked at security groups, which are firewalls, right? And we looked at key pairs, which are ways of authenticating, right? These are authentication mechanisms, especially used on the Linux side. But we also saw that on Windows side, even though you need to log in using passwords, right? There is there's an extra step there where you can generate the password using the private key, right? And also we looked at IP addressing as well, right? So we saw the difference between private IP, public IP addresses, and also elastic IP addresses, right? So these two are important topics as far as EC2 are concerned. We also looked at Linux, how to launch a Linux server, how to launch a Windows server, how to connect. Right? How to connect to these servers. On the Linux side, you use an SSH client. On a Mac, this could be a terminal program. On a Windows computer, right? If you have a Windows laptop or a computer, you normally would use PuTTY, which is a Windows-based SSH client, right? And if you have a Windows server, then you need to connect using an RDP client. Microsoft Remote Desktop client, right? So that's what we've seen. We also saw last week how to set up an application on an EC2 instance. We saw how to set up WordPress on a Linux server. You can do the same on a Windows machine as well, right? You should basically stick to what you know and what you're going to use in the future, right? So if you're more of a Windows person, you should stick to Windows. If you're more of a Linux person, stick to Linux. And also, you can choose any Linux distribution that you are familiar with. All right, so this is what we did. This is what we did last week, and now, right? Let's move forward with this week's agenda, which is storage. All right. So today we look at a few storage services. So these are EBS, Elastic Block Store, S3, Simple Storage Service, Glacier. These are important services. And then if you look at more from an enterprise point of view or a hybrid cloud point of view, there are a couple of services which are interesting as well. So a storage gateway, for example, this can be used to move data from your on-premises servers to the cloud, right? And also to have maybe some caching locally. There are 2 or 3 different configurations in which you can use storage gateway. And then Snowball is a hardware device that can be used to move large amounts of data from your on-premises servers to the cloud. Right, so we'll talk about these two, but mainly our focus is going to be on these 3 services: EBS, S3, and Glacier. Right, and before we look at these, we'll do a little bit of conceptual. We'll look at some terminology. We'll look at especially how storage is managed in traditional data centers, right? How storage used to be managed, and then what are the equivalent services in the cloud, right? Because when you're considering using the cloud, especially a lot of people have existing server rooms, data centers, and they have to migrate, right? So you need to be able to map what's going to go from how the data is going to move from your existing data centers into the cloud. Right? So we'll just try to understand that stuff a little bit, and then we'll get into these services. All right. So let's all right, let's get into this. I'm sorry, I have there's a little bit of a problem with the LMS and the webinar tool. So sometimes I have to minimize this before we move forward. All right, so let's look at a few terms and terminologies. Let's understand this. All right, first of all, we need to know that there's a volume, there's a concept called volume, and there's a concept called vault, right? And volume is essentially a storage device. It's used for current data, active data, right? And a vault is a term which is also a storage device, but usually used for archival data. Right? So we'll be using these terms later, just making sure that you are familiar with these terms. All right, and if you look at storage, right, especially in the enterprise world, especially before cloud, storage, there were multiple types of storage, right? And you can look at this slide, a very good slide in my view. And there are 4 tiers, right? Tier 0, 1, 2, and 3. And the top tier is usually faster, right? The performance is better, but also it's more expensive, right? It's more expensive, and also the pyramid, right, signifies that at the top you normally have a very small amount of data which needs that kind of performance attributes, right? So at the base you have tier 3, which is the cheapest, but the slowest, right? And also you tend to have a lot of data at the base because this is usually archival data, right? Which collects over time. That's why it becomes a lot more than the stuff in the upper tiers, right? So the way this happens is the top 2 tiers, tier 0 and 1, are the volume data, right? And then tiers 2 and 3 are the vault type of data where you have more archival stuff, right? And also on the right side of the slide, you can see there are some technologies mentioned. So SSD is solid state devices. These are more expensive, but they're faster, right? And then below that, in tier 1, you have HDD hard disk drives, which are slower than SSD, right? But still pretty fast. And then there are other types below that, right? So you have slower hard disk drives, and then at the bottom you have tape storage, right? Tape storage, which is a very different kind of storage. So this is what is commonly used in many enterprises around the world, right? So we're trying to look at this so that we can understand what's available on AWS and what's tier 0 on AWS, what's tier 1 on AWS, right? So that's why we're trying to look at these concepts. All right. Okay. Let's also look at some of the problems with respect to storage in traditional data centers. right? So, for example, if you just to look at the first two items, right? The first item says that that most of the storage that you have in these data centers is idle, right? It's just idle, and and uh, uh, essentially the figure here is, this is probably from some research, right? And the figure is 40%. 40% of storage is not really used; it just is lying idle, and this happens because you normally buy storage in chunks, right? So you may buy a storage device which has X terabytes of capacity, and you don't really have the flexibility of buying smaller chunks, right? The way you have it in the cloud. So this is one reason, and also the other reason is in a lot of companies you have a budgeting process, and you tend to buy for the future, right? So you tend to look at, okay, what do I need for the next few years, right? And you tend to buy over that horizon. Often assuming the worst case, right? Often assuming that you'll probably need much more than you actually end up needing, right? So because of these purchasing cycles, you end up with this sort of problem where you have a lot of capacity which is lying idle, right? But on the cloud, the way it works, especially with things like with S3 or even Glacier, is that you don't buy in large chunks, right? You don't have to buy in 5 terabytes, 1 terabyte, or anything like that. You can simply add your data, add your files, add your images, add your videos to the storage service, and you simply pay for what you use, right? So you could have an S3 bucket which has just maybe 1 MB of data, right, or even 100 by 100 KB of data, right, and you build only for that amount, right, and you can add as fast as you want. You can add more data as fast as you want or as slow as you want, right? So there will be no idle capacity, right? There will be no idle storage in the cloud because it's all completely incremental, right? And it's completely pay as you go as well, right? So this is a big solution, right? It's a big. It used to be a big problem, a lot of money locked up, right? And that problem is completely gone with the cloud. Right. Okay. The second problem is also very important, right? If you look at this, it says that a lot of inactive data is sitting in storage which is meant for active data, right? So often, and the figure is really high. You can see here it says 95% of data that's there in expensive storage need not be in that expensive storage, right? It can be moved to cold storage. So this could be, for various reasons. Maybe people don't have the time to plan this out properly, right? Maybe they're not aware, right? Or maybe there's problems in the purchasing cycles. You're not able to buy cold storage equipment, right? Maybe there's lack of capital. So lots of reasons why people end up in this situation where they are using the wrong storage for the wrong type of data. Right? And what you can do for this problem in the cloud is you can easily set up some lifecycle type of rules where data moves automatically from more expensive storage to cheaper storage. Right? So you can write your custom scripts, or you can also use AWS's own capabilities to do this in a very simple manner. Right? I'll show you this, and it's a very simple mechanism where in a fully automated fashion, data is moved from expensive storage to cheaper storage. All right. Okay. So these are some of the problems that you see in traditional storage, and you can see how cloud is better. Right. You can review this slide in a little more detail later as well. Right. But the general point is that cloud is much better. Right. It's much better when it comes to storage. And we'll see, some examples of this today. All right, just one more, one more slide here. This is from an IBM survey, right? Probably of CIOs or CTOs, and here what you're seeing is, when you use hybrid storage, right? So this is enterprises who are trying to use both, right? They have existing investments in their data centers. They can't get out of those right away, right? But what they're doing is, instead of investing more in their existing data centers, they are extending their capacities by using the cloud, right? So they're basically trying to do some sort of hybrid storage strategy, and what they are seeing on the average is that the storage budget is about half the budget, right? So those who are doing hybrid strategies are seeing a significant saving in their spend. All right, now let's, this is a little bit, a quick overview of, the problems, the situation in traditional enterprises with respect to storage. Now let's talk about cloud. All right, now on the cloud, right, you have services which are completely managed, first of all, right? So you don't have to worry about the hardware, right? You don't have to worry about buying hardware, setting them up, maintaining them, replacing them, securing them, right? So it's completely managed, right? You don't have to mess around with that. You are only a user, right? So using web services over the internet, you can just access these storage, this storage services, right? So that's the key bit here. It's completely managed and available over the network, right? And often a lot of these storage services have very high durability, right? Which means the chance of data loss is very, very low. And the way it is done is AWS backs up that data on its own, right? In a fully transparent, automated fashion. You don't even know, but essentially what they do is they take your data and they copy and they make multiple copies of that data, right? Sometimes within one zone, sometimes within one region, right? So so in this way, they are able to have very high durabilities of for your data, right? So that the creation of multiple copies is also fully automated. Right, so these are some benefits. Now, also on the pricing side, right, you have usually you pay per use, right? So there's no upfront cost the way it used to be in traditional data centers, right? So you can use as much as you want. You can start anytime. You can stop using anytime. You can change the usage, right? And you only pay based on your usage. It's pay per use. In some cases, there could be some monthly rates as well. All right, now let's talk about specific services, right? So we will talk about EBS, S3, and Glacier, right? First, so EBS is what is called elastic block storage, right? So it's block storage, and elastic simply means it's scalable, right? You can stretch it like a rubber band. You can essentially increase the capacity quite easily, right? With elastic block store. So this is block storage, and the simplest way to think of to imagine EBS is to think of these as hard disk volumes, right? So they're like hard disks attached to your servers conceptually, right? Conceptually, they're like hard disks, but architecturally, right? In reality, they are not hard disks. They are actually network-based storage, which are available, which are connected to your EC2 instances over a network, right? So that's how they're actually implemented. But conceptually, as well as from an operating system, the way you would use a hard disk volume is the same way that you would use an EBS volume, right? So so these volumes are actually accessible only from the operating system of your EC2 instances, right? So that's what EBS is. These are persistent storage. So once you save data in these volumes, they don't get deleted, right? Even if your EC2 instance has a failure, even if you terminate your EC2 instance, right? Your EBS volume can survive independently, right? And your data is safely stored in these EBS volumes. All right. Now this is one, right? The other important storage service is called S3, Simple Storage Service, right? And this is called an object storage. So it basically has there's an object which could be, say, a picture, a video, some sort of database backup file, some sort of log file. It could be anything, right? Anything can be stored as an object in S3, and then each object has some metadata, right? And also it has a unique identifier, right, called the key. So this is S3 is a fantastic service because it's highly durable, highly scalable, highly available, right? And you access these objects over HTTP protocol, right? So EBS is accessible from the OS like a hard disk. S3 data is accessible over HTTP protocol, right? Web services. All right. Okay. So these are two key services. Now within S3, right? S3 is a service which has different storage classes, right? So there are S3, there's S3 standard, and then there are cheaper versions which have lower SLAs, right? So there's a storage class which has lower durability, but it's cheaper. There's Glacier also is a storage class within S3, and Glacier is 1/5 the cost of standard S3. But the downside, right, because it's cheaper, you lose some capabilities there. And what happens with Glacier? It's very slow to work with, right? So when you upload or when you download, it takes a lot of time for the stuff to become available, right? So Glacier is an important service because you can store long-term archival archives, right? Say database. Banks need to store data for a long time, say 7 years, 10 years, right? So you want to store data, that kind of data in Glacier because it's highly durable, it's very, very safe, right? And very cheap as well, because remember that pyramid, right? Long-term data becomes very large, right? Because it's collected over a long time. So you're looking for a service which is extremely low cost, right? But at the same time, you want high durability. You want the data to be safe, right? So Glacier is a perfect fit for that kind of those kinds of needs. All right. Okay. So now mapping it to the tiers, right? Mapping it to the tiers. So EBS would fall under tier 0 and tier 1, right? So this is EBS is fast. It's fast. It's more expensive. Within EBS, there are different types of EBS volumes, right? Some are cheaper, some are more expensive, and obviously the more expensive ones are the fastest types of volumes, right? And S3 would fall would come under tier 2, right? Tier 2, and then Glacier. Finally, Glacier is the one that is the tier 3, the last tier, right? Most of your data should sit in Glacier, right? Should sit in Glacier. It's the cheapest storage option available. And we also spoke about the problem number 2, right, where 95% of the data is sitting in the wrong storage type. Now here what you can do is you can have some data in S3 and then create a rule where it automatically moves into Glacier, right? So that's a fantastic feature. We'll talk about it more. All right, now let's talk about some enterprise, some hybrid cloud type of options a little bit, right? So one is called a storage gateway, and the other one is called Snowball, right? And this is a storage gateway is essentially it's an appliance which sits in your on-premises server room or data center, right? And it talks to the cloud backend, which could be EBS, S3, Glacier, right? And there are many different configurations. You can have all the data stored in the cloud with a cache kept locally, right? Or you can have all the data stored locally with a snapshot in the cloud, right? And you can also have a tape library sort of setup where you have stuff stored in Glacier, right? So that's storage gateway, good for a hybrid type of environment. All right, Snowball is an interesting service. It's a hardware device which is rugged, right? It's tamper-proof, rugged, and also very secure, right? And it's used when you have lots of data to be moved, right? For example, if you're migrating data, right? Initially, you may have lots of data to be moved to the cloud. You don't want to do it on the network over the internet because it may clog up your internet connection. It may be too expensive. It may be too slow, right? So it might make sense under those situations to request for a Snowball. And this is a device which is shipped to you, and you stuff your data into it, and then you ship it back to AWS, where they will download your data into the appropriate service, right? So these are a couple of other services which are interesting. All right, so a little more, just a quick look at some of the terms, right? I just want to make sure we just want to make sure that you have some understanding of these terms, because these will come into play when we look at these services. All right, so you have SSD, right? SSD. These are faster disks, actually, solid state disks. There's also HDD type hard disk drives, which are more traditional volumes, right? So SSDs are the faster drives. All right. Now, on the performance side, right, all these, especially EBS volumes, right, you need to measure the performance. You need to have an idea of, what are the different types of EBS volumes, what kind of performance you can expect, right? So some of these measures are IOPS. One measure is IOPS. This is input output per second. Simply, the number of reads or writes that are happening per second, and you'll find that SSD type of volumes have a higher IOPS performance. All right. Okay. And then the sizes, right? You need to know. You need to understand the sizes. So basically, there's gigabytes and there's terabytes, right? Gigabytes, terabytes, and megabytes. So the smallest one is kilobyte. About 1,000 kilobytes is a megabyte, 1,000 megabytes is a gigabyte, and 1,000 gigabytes is a terabyte, right? And then you have petabytes as well, right? So these are some measures, smallest being kilo, next mega, giga, and tera, right? And there's small differences in how these are calculated. For example, terabyte is equal to 1,000 gigabytes, whereas tebibyte is equal to 1024 gigabytes, right? So there's a little bit of difference in how these are defined. AWS uses these ones, the ones on the left, right? Tebibyte, gigabyte, and megabyte. But there's a very small difference with terabyte, gigabyte, and megabyte. All right. Okay, so with that, let's look at EBS first. Then we look at S3, and then we look at Glacier. All right, so this is, EBS. These are block level storage volumes. These are very much like hard disks, right? Conceptually, they're very much like hard disks attached to your EC2 instances, and these are used for active data, right? Active data, for example, databases, right? MySQL databases, MongoDB databases, Cassandra databases, right? So it's ideal for data which changes a lot, right? And also where you need to store the data carefully, right? It's for data that needs to be persisted safely, right? So it shouldn't be. It's not volatile storage where you lose data. All right, and if you look at the slide, right, the image here is absolutely right in that you essentially use EBS volumes from your EC2 instances, right? And there's there's a network in the middle, right? So these are not hard disks which are physically attached to the host, right? These are network-based storage, and there's a network between EC2 and EBS. All right. Now within EBS, you'll look at two terms, right? One is volume, and the other is snapshot. Right. So volume is essentially the sort of the device or the logical volume, right? It's a logical volume where all your data is actually stored, right? That's the volume. And then a snapshot is a copy, right? It's a copy of the EBS volume. It's a copy of the EBS volume at a certain time. Right? That's why a snapshot, right? It's like a picture that you take using your camera. So that's the idea. It's a snapshot. It's a backup of your EBS volume at a certain time, right? And the key thing about EBS snapshots is snapshots are stored in S3, right? They are stored in S3. S3, as you know, is a lower tier service, right? It's cheaper. And also, it's highly durable, right? S3 is highly durable. It is more durable than EBS volumes. So when you take a snapshot, it's actually very, very safe, right? A snapshot is stored very, very safely in S3. All right, and snapshots, by the way, are also incremental. They are also incremental. So if you take a snapshot of an EBS volume today and then take another snapshot tomorrow, right? So tomorrow's snapshot only includes the stuff that has changed, right? So that's an interesting mechanism of EBS snapshots. All right, okay. So these are some key ideas here. All right. So basically, this picture as well, right? It gives you some additional information. For example, EC2 talking to EPS is over a network. Right? This is very important to understand. There's an Ethernet communication. There's a network between EC2 and EPS, right? And from the EBS volume, you can take a snapshot, right? A snapshot is a point-in-time backup of your EBS volume, and the snapshot is really stored in S3, where it is extremely safe, right? And using a snapshot, you can recover, you can create a volume, right? You can create a volume using a snapshot. So it's possible to essentially recover. If there's a hardware failure with your EBS volume, you can recover using a snapshot. All right. Okay. Now, EBS volumes have certain restrictions, right? What happens with EBS volumes is these are created in one availability zone, right? And they cannot be moved. They cannot be moved from one availability zone to another, right? That's one limitation of EBS volumes, and therefore you can only attach an EBS volume to a EC2 instance in the same zone, right? This is one important aspect. All right. The EBS volumes are independent entities, right? So although they are only accessible from EC2 instances, right, they are independent of the EC2 instances, which means that you can actually, detach, right? You can detach an EBS volume and attach it to some other EC2 instance as well, right? And also at the same time, the EBS volumes are independent of the state of the EC2 instance, right? For example, an EC2 instance may be in a running state, the EBS volume is attached to it, and if the EC2 instance is stopped, right, EBS volume is still attached to it. If an EC2 instance is terminated as well, right, if you terminate an EC2 instance, even then the EBS volume can survive, right? It is independent of the EC2 instance. All right. There's also encryption. There are some encryption options available, right? There are lots of industries lots of companies where encryption is very important. Lots of use cases as well, right? For example, if you're storing credit card information, you probably need to have encryption of your data in these EBS volumes, right? So AWS gives you out-of-the-box capabilities for encrypting your EBS volumes, right? So all the data is encrypted end-to-end. Transparently, right? You don't even have to do anything on your side. It's encrypted transparently to you, right? And the snapshots as well. So if you take a snapshot of the EBS volume, that also is encrypted. All right. Okay. Okay. Now, just a few more slides, right? And then I'm going to show you some demonstration of these things. But let's just go through some of these important conceptual things about these storage services. All right. Now, there's also, different types of EBS volumes. So there's, general purpose, right? The one in the middle is the most commonly used general purpose SSD. These are solid state devices. And then there's provisioned IOPS volumes as well. These are faster and also they have more consistent performance. And of course, they're more expensive. Right? They are more expensive. So normally you would use this test environments, development environments, proof of concept, small applications, small databases, right? General purpose is fine for most use cases, but if you have a serious application, live environments, production environments, right, you'd probably want to go with provisioned IOPS. It also depends on the use case, right? So if you have a large database, a large NoSQL database, you probably need provisioned IOPS, right? And for most other cases, general purpose is fine. Right? And magnetic volumes are also an option. These are older storage types, and these are very cheap, right? They're very cheap, but their performance is not high, right? So there could be some use cases where you can use magnetic volumes, especially for storage, right? You can just store stuff using magnetic volumes, right? And you can see here, the performance differences, right? There's a throughput. This is the amount of data that can be transferred to and fro from the volume per second, right? Provisioned IOPS support double the capacity of general purpose, right? And the magnetic is only 1/3 the capacity of general purpose, right? And input output per second, right? This is what is important for things like databases, where you can read and write really fast, right? And you can see that provisioned IOPS give you a much higher maximum IOPS performance compared to general purpose. All right. Okay. So, and of course, the pricing, right? The pricing will be different as well. So, by the way, when you run EC2 instances, right, and you use EBS volumes, so you pay for the EC2 instances separately, and in addition, you pay for the EBS volumes separately as well, right? So remember, the cost is not just the cost of running the EC2 instance. You also have to add the cost of EBS volumes, right? And when you take a snapshot of the EBS volume, there's a separate cost for the snapshot as well. Right, and you can see here, this is provisioned IOPS volumes are much more expensive than general purpose. All right. Now, by the way, there are a couple of other new EBS volume types as well. HTT types. We'll discuss that separately. All right. Okay. Let me stop here. Right. Let me stop here. Let's see if you guys have any questions on what we've discussed so far, right? I have this, using the same document, but I've created a separate spreadsheet, right? So we can use this sheet for this week's modules, right? So if you don't have this document, please let me know. I will share it with you. In fact, let me just share it with you in any case. All right, so I'm going to send you this link right now. All right, so what we're discussing today is storage, right? And we've talked about the traditional storage, the 4 tiers, right? And we're trying to see what are the equivalent services available in AWS. And we're talking about EBS, S3, Glacier, Storage Gateway, etc. All right. So while you guys are typing your question, let me start answering. Tony, what's the difference between a stopped and terminated instance? All right. So stopped is essentially where you can restart, right? You can restart that instance. Essentially, the server is not functional, right? The server is down. Right? But the benefit of stopping it is that you can restart that instance at any point later, right after you stop it. And what happens is you are, from a costing point of view, from a billing point of view, you're not billed for the EC2 instance hours, right? While the instance is in a stopped state, right? So this will save you some cost. Right, this will save you some cost, and also you can restart the instance at a later point, right? But remember, you're still billed for the storage, right? For the storage, the EBS cost, right? Because you're still using up the storage, right? Whereas termination is complete, removal of the server. Right, you can't get it back. And you normally also your billing completely stops. Right, you're not being billed for anything, not even storage associated with that server. Right, so your billing completely stops as well. But the server is gone. Right, server is gone forever. You can't get it back. All right. Okay. So this question here, Mukesh, can you give real-world examples when different tiers of storage should be used? Yeah, sure. So let me go back to that slide, right? So I think it's an important question. Let's talk about this a little bit. Okay, so this was a slide, right? So you have 4 tiers, and what we said is at the top you have the least amount of data, but this is the active data, right? And usually these are high performance devices, and also the cost is higher, right? And then at the bottom you have cheaper, you have cheaper, um, uh, you have cheaper storage, but more amount of data. Okay, so normally, right, what you would have here on the top is stuff like databases, right? So tier 0 would be databases, and just giving you some examples, right? There could be other types of services, other types of data as well. So tier 0, right? Tier 0 would be databases, right? Okay, tier 1, right, which is as you can see here, these are you know fast, right? They're fast, but not as fast as SSD volumes. And here um, uh, you can keep say non-production databases, right? Maybe you have other types of data. For example, you have images, you have video files, etc. Right? So these, tier 0 is databases, especially production, right? Especially high volume, high performance type of use cases, right? Tier 1 can also be databases, right? And also other types of storage, other types of information, other types of files that you may have, images, video files, etc. Right? So these are usually the more expensive ones, and then you have tiers 2 and 3. And tier 3 especially, right? Tier 3 especially is long-term archival. So for example, you may have database backups stored for X years, right? Or you may have log files, or you may have digitized material, right? So you may have some stuff that you scan into images and then you store for the long term, right? Digitize archives, right? Stuff like this. So and tier 2 is somewhere in the middle, right? Tier 2 is somewhere in the middle. Although tier 2 and 3 are both sort of long term uh, storage options. All right, so Yalla, I'm going to send you the link once again. Here's the link. I hope this one works for you. All right, and let me also copy one question here from Sanjay, which Sanjay sent on the webinar panel. All right, and Greg, your question is, does AWS have virtual tape for backups? For example, if a customer has legacy tapes and they want to move them to AWS, would that be done with a storage gateway? Yeah, so you have a service called Glacier, right? We'll talk about this more today, but a Glacier is the equivalent, right? This is the equivalent to tape backups, right? So like a virtual tape, as you say, right? And you can move stuff from your existing tapes, from legacy tapes to Glacier, right? Directly, right? You can do this directly by writing some sort of script, writing a script, for example, right? So so you can move stuff directly as well. You don't have to use storage gateway, right? Storage gateway is more of for sort of a hybrid environment where you have some ongoing, right? You have some data locally, and then the data is either backed up on the cloud, or you have data on the cloud and you have a cache locally, right? So storage gateway is more for a hybrid environment, right? You can do it both ways. You can keep data in Glacier using a storage gateway or not. All right, okay. Sanjay, how do we detach EBS storage so that we don't get billed? No, so as long as you have an EBS volume, right? As long as the EBS volume exists, right? You will be billed, right? So the only way to stop billing is to terminate, right? Or to delete. So terminate or delete the EBS volume to stop billing, right? So whether the EBS volume is attached to a server or not, it doesn't matter, right? You have an EBS volume, some data in it, even if there's no data in it, right? You have an EBS volume that you have created, you will be billed for it unless you delete it or terminate it. All right. Okay. All right. Okay. So let's move forward. Right. Let's move forward. Let me go to where we were. Um, all right. Why don't we do these things? Right. Let's test ourselves. Maybe you can let me know what you think. Right. So the first question here is for cold storage data, which EBS volume type, right? These are EBS volumes, right? We're not talking about S3 or Glacier, only about EBS volumes. What do you think is the type that is best for cold storage, inactive type of data? All right, so yeah, Paul, thanks for that. So what you're saying is option C, right? Option C. Ratish, you're saying C as well. So that's actually correct, right? So it's very clear. Magnetic is the one that's for storage. It's very cheap, right? It's cheap. Remember, the inactive data is much more in size, right? Because it collects over time, right? So you need cold storage to be cheap, and magnetic is the one that is cheapest. But also this type of data is inactive, right? Remember, magnetic volumes are very slow, right? You'll probably not be able to do databases and those sorts of things with magnetic volumes, right? All right, so this is right. And then what about the fault tolerance, right? So what happens if there's an availability zone failure, right? What will happen to the EBS volume, which is in that availability zone, right? So first option is no, right? It can't survive the zone failure because EVS volumes are in a single zone. Two, it will survive a zonal failure because EVS volumes are copied multiple times, perhaps across the zone, and then some other options. Basically depends. Right? It depends. Um, All right. Okay. Greg, option two, you're saying A. Paul, you're saying C, right? You're saying C. Well, the right answer, right? Let's look at the answers here. The right answer is actually A because EBS volumes, they have, EBS is, it's a little different, right? EBS is different from S3, for example. S3 is highly durable. S3 is highly durable. It has 11 nines durability because data is stored across the region in multiple zones, right? And not so with EBS, right? Not so with EBS. EBS is one service where the volumes are in a single zone, right? There are multiple copies of the data, but all the copies are in the same zone, right? So if there's a zonal failure, you will lose the data, right? You lose the data. So this is one limitation of EBS volumes. All right. So EBS volumes are, they are only within a zone and they cannot survive a zonal failure. All right. So now let's talk about S3 a bit, right? And then I'll show you some demonstrations for both EBS and S3, right? And I'm showing you S3. We're talking about S3 first because we can then compare EBS and S3, right? And then we have to think about what are the applications of these two services. All right. So essentially, S3 is an object store, right? An object is, let's not worry about what an object is. It's basically any type of data, right? It could be an image, it could be a video file, it could be a database backup, it could be a HTML file, right? So anything really. Any sort of file, any sort of data can be stored in S3, right? And each item that you store in S3 is called an object. It has a key, right? A key is a unique identifier of that object, and also you can optionally have some metadata associated with that file, right? And these objects are stored in what is called a bucket, right? A bucket. A bucket is like a as the name signifies, right? It's just a unit of, it's a way of organizing your content. It's a entity under which you can store buckets. A bucket can, by the way, also have folders, right? So within a bucket you can have folders. Those folders can have subfolders, and then have objects stored directly in the bucket or in the folders or in the subfolders. Right? That's how it works. And you can store objects, any number of objects. There's no limit, right? By the way, this is a truly cloud-like service, right? We have seen EC2 so far, right? And I would say EC2 is not really a pure cloud service. It sits somewhere between cloud and traditional, right? Because these are basically virtual servers. Virtual servers existed before cloud as well, right? So EC2 is a service which is easy to understand, easy to use, because we've all used it before, right? But if you look at S3, it's more of a cloud service because it's completely elastic, right? You can have any number of objects. You can store as much as you want. There's really no limit. But the limit is that each object can only be a maximum of 5 terabytes, right? Which is pretty large in itself. Most people don't need more than that. All right. Now a bucket, right? A bucket is, like we said, it's a way to organize your objects or your files, right? And a bucket can have many objects. There's no real limit, right? And but the bucket is created in a specific region, right? So EBS volumes are created within a region, and also in that region within an availability zone, right? An S3 bucket, however, is created in a region, yes, like EBS. However, it belongs to no particular availability zone, right? So that's very important. It has lots of implications, but basically it's available at a region-wide level. All right. Okay. And I think the example at the bottom is a good one. You can see here it's a bucket. Let's say John Smith, and within this you have a folder called Photos, and within that folder you have an image, right? And then S3 is accessible over HTTP, right? So any object that you store in S3 is available using HTTP, a URL essentially, right? So there will be a URL for every object that you have in S3, right? So you can see this is very different from EBS, right? EBS volumes cannot be accessed in this way, right? The data in an EBS volume, you could have the same image in EBS, but you won't be able to access that image using a URL, right? You can only access it from the operating system, the way you access any normal hard disk, right? So S3 and EBS are very different in the way you access them, access the data as well. All right. Okay. So so the way this works is, the user can upload you can upload your objects into a bucket over the internet, right, using HTTP protocols, and every object has to go into one bucket or the other. It has to go into one bucket or the other. All right. Okay. Now, this slide, what we're trying to explain here is that normally when you create an application, right? Now let's try and imagine you have an application. Let's say you have an application like Facebook or maybe Instagram, right? And essentially you have it could be a Java application, PHP application, whatever, right? So what would happen is you would run your application on EC2 instances, right? Your database would probably be on EBS volumes, right? And then let's say if it's Facebook or Instagram, there's lots of images, right? There's lots of images. So normally what you would do is those images would be images or videos or whatever would be stored on S3. It would be stored on S3, and then in your application you make the S3 images available, right? The URLs of those images would be included in your application so that the user can access the images from S3, but via your application. Right? So normally when you create an application, you have to use EC2 instances for your application. You have to use EBS volume for some local storage, especially databases, right? And then you can also use S3, right? So these are all complementary, right? EBS and S3 are complementary services. You often have to use them together. All right. a few more points, right? In S3, what happens is S3 is not just a storage service; it has a way of controlling access, right? So with EBS volumes, what happens is the data in EBS is safe because you can only access the data in EBS through the OS, through the operating system, right? So to access the data, you need to go through the operating system's security mechanism, right? So you need to have a user account on the OS, and you need to have the permissions, right? So that's how the data is kept safe on EBS volumes. Now S3 is a storage service where data is available over HTTP, right? So if you have the URL, you can access the object, right? So therefore, S3 has to have a security mechanism, right, built on top. And there are multiple ways. There are multiple ways of controlling access to stuff in the S3 buckets, right? So one way is this is called access control list, right? There's a typo here. It's called access control lists. So you can essentially take any object and you can grant some permissions, right? So you can say, look, everyone can have access to it, or a specific AWS user can have access to it. So this is a simple way of controlling access, right? But there are other ways as well. For example, you can use bucket policies. So these are policies written in a JSON format at a bucket level, right? And there's also you can also control access using IAM policies. These are policies at a user level, right? So we'll discuss IAM more in a future module, right? And today I'm going to show you some bucket policies, which are basically permissions at the bucket level, right? So we'll talk about this. Yeah, this is just an example of what a bucket policy looks like, right? I'll explain this to you, but you can see it's a JSON-like structure, right? You have nested brackets, and essentially you create a policy that allows or disallows access to a certain resource, which could be a bucket or an object within a bucket, and then you can also decide who gets access, right? Who are those people who get access to those resources. Right. So the big picture, right? The big point is that S3 is not just a storage service, right? It's a service which has security, right? Which has access control, a very granular, very strong access control built on top of it. All right. Now this is an important point here, right? So S3 has storage classes, right? And this is this was not always the case. Initially, there was only standard S3, and then later they came out with more storage classes. I guess in response to market demands, right? So S3, for example, right, the standard S3 it's a very good service, as you can see. Its durability SLA is 11 nines. Right, 11 nines, which means 99.9 nines, and this essentially means that if an object is stored in S3, the chance of loss of data is zero, right? It's effectively zero, right? And they do this by creating many copies of your data in many different zones within one region, right? So this durability is extremely high. It's extremely high durability. Your data is very safe. Right. In fact, the chance of data loss is more from user action, right? Accidental deletion, accidental updates, and less from any problems with the storage, right? And also, it's highly available as well. It's highly available. 99.99% means that it's hardly ever unavailable, right? It's hardly ever down in a month or in a year, right? So highly durable, highly available. And also, of course, it's highly scalable, right? There's really no limit to the number of objects you can upload on S3, right? So fantastic service, high durability, high availability, high scalability, right? And also, it's quite cheap. If you look at it, if you look at the pricing, it's quite cheap. All right. So what has happened is the market, right? The market has told them, look, I don't need this much, right? I don't need such a high durability. Maybe I can compromise on availability as well, right? I have certain types of data where I don't need this much, right? Can you give me something which is cheaper, right? Which is cheaper, and I'm willing to compromise on some of these characteristics, right? So that's what probably the market has been telling them. And also remember the first few slides where we said lots of data. There's different types of data, right? And you should not be storing inactive data in expensive storage, right? So that's another reason why they have come out with more storage classes, right? So for example, you have these classes where you have there's one called infrequent access, right? Infrequent access is stuff that you want to be safe, right? You want this stuff to be safe, but if you don't really access it too often, right? You don't need it too often, very rarely, right? So then you can afford to have lower availability, right? You can see here it has 99.9% uptime, right? Whereas standard has 99.99% uptime, right? So because of this lower availability here, you get some discount, right? So this is, I think, half the price. It's half the cost of standard S3. Right, and by the same token, there's another storage class called Glacier, which has you can see the same durability, right? Your data is very safe. All three classes have the same durability. Data is very safe. However, the availability is NA, which means essentially, it's a very different kind of service. If you want to download something from Glacier, you have to wait for at least four hours, right? You have to wait for 4 hours, and because of this, the way it is set up, the way it is designed is we're able to cut down the cost a lot by removing the availability SLA, right? So you can see essentially there's a trade-off between cost and the characteristics, right, and the performance aspects of that storage class, right? So where would you use this? Infrequent access is where you have stuff which you don't retrieve. For example, long-term databases, right? Long-term databases or medium-term databases. Maybe database backups which are a month old, 2 months old, right? Those kinds of things can sit in infrequent access, right? Because it's highly unlikely, right? It's unlikely, not highly unlikely. It's unlikely that you'll need those files, right? And long-term storage, maybe database backups from a year back, 2 years back, can be stored in Glacier because you will, it's highly unlikely that you'll need those files, right? And of course, active stuff, right? Active stuff can be kept in standard, right? Okay, so these are storage classes that are available, and there's also another option, right? There's another option called reduced redundancy storage. Right? Reduced redundancy storage. This is an option which is obviously cheaper than standard, and here the durability, right? The durability is lower. So you have only 4 nines durability, whereas you can see in the previous slide, all these options have 11 nines durability, right? So this is an option where the chance of data loss is higher, right? The chance of data loss is higher. So it is often used for use cases where it's possible to recover that data from some source, right? Often, for example, used in image transcoding, where let's say you have an original image, and from that original image you create, say, black and white images or images of different sizes, right? And if you lose that data, if you lose the black and white image, you can go back to the original one and recreate that image, right? So you often use reduced redundancy for use cases where the data can be recovered by other means, right? So because it has a lower durability, the cost is lower as well. All right. Okay. So these are some options here. Let me stop here. We'll discuss S3 more a little bit later. But let me stop here. Let's look at some questions, and then I'll also show you these things. Right. I'll show you EBS. I'll show you S3 a little bit, and then we'll look at Glacier and the other stuff. So looking at some of these questions here, Mukesh, what is magnetic? Is it tape or HDD? So it's HDD, right? It's HDD. It's not tape. It's not tape, right? But within HDD you have different types, right? And magnetic is one of the slower types, slower and cheaper. Right? So magnetic volumes are slower and also cheaper. All right, Mukesh, how is durability and availability related? No, they're not. They're not really related. Right? So durability is essentially what are the odds of loss of data? Right? Chances of data loss is what we are looking at here, and availability is uptime, right? Availability is uptime. So that's what these are. Uptime of the service, right? Uptime of the service. So you can, when you need your data, you get it, right? That's what availability is. All right, Ratish, in one of the earlier EBS slides, was it mentioned that they cannot be replicated to other regions? Yeah, so the EBS volume, right? EBS volume stays within one zone, right? It stays within one zone, and of course that also means it stays within one region, right? So EBS volumes are very unlike S3, right? S3 is accessible from any zone. EBS is accessible from only one zone. However, you can copy the data, right? You can copy the data. So what you can do is you can create a to copy the data or to copy the volume, right? Data or the volume, you can take a snapshot. EBS snapshot it's called, right? And the EBS snapshot is in S3, right? Snapshots are stored in S3, which means snapshots are available in the whole region, right? Snapshots are available in the whole region. And snapshots are available across AZs, right? So basically, your EBS data can become available in the entire region, but via a snapshot, right? Via a snapshot, and also EBS snapshots can be copied. Right? They can be copied into other regions as well, right? So for example, if you want to create a DR site, right, then you can periodically copy your EBS snapshots to a second region, right? And then you can bring up your servers and your EBS volumes in the second region when the need arises, right? So you can do what you want to do, right? But in an indirect sort of way. Yeah. So exactly what you're saying here. You're thinking of a DR scenario, and what you want to do is take a snapshot and keep it in a different region, right? So what you would do is you'll create a script, right? You create a script which takes a snapshot and copies to second region, right? This is like a 10-minute script. You can create a script in 10 minutes to do this sort of stuff. Yeah, so Paul, I think you're saying you're saying zone, not region, right? I'm sorry, maybe I've seen this late, right? Maybe I've seen this comment a little bit late, and okay, so maybe Paul, what you're saying is Ratish's question is referring to replication across zones, right? Yeah, so maybe the slide was talking about zones rather than regions, right? Maybe Paul is right there. That the slide was probably talking about copying across zones within a region, right? Yeah, but I think this is how it works, right? EBS volume stays within one region. Let me add here, looking at Paul's comment here, the EBS data, right? The EBS volume data is replicated, right, within one AZ, right? So there is a built-in, there's a little bit of automated backup built in, but the replication or the copying of data is only within one AZ. And the script can be scheduled in a cron tab or Windows scheduler, right? So you can easily create solutions for DR using EBS snapshots. All right, this question Ratish, how many snapshots can be taken and how frequent? Well, that's up to you, right? That's up to you. So remember, there's a cost, right? Each snapshot, there's a cost to a snapshot. Storage cost, right? It's essentially storage cost for each snapshot, but there's no limit, right? There is no limit. You can take as many as you want, right? But usually, right? Usually, what you would do is probably a nightly job for databases, right? Maybe a weekly, monthly for other types of data. Let's say application server volumes, right? Those can be taken less frequently. But if you have databases running, then you probably want to do it on a nightly basis. All right. Okay. All right. So let me show you. Let me show you this stuff, right? We'll discuss this more, but I think let's start looking at some of these things. First, I'm going to show you this stuff, right? How do we create from a snapshot? How do we create an EBS volume, right? And before that, I will show you how to create a snapshot from an EBS volume as well. Right? So this is something we'll see. And then after that, I'm going to show you how to use S3 for creating a website. But S3 is, given its characteristics, right? Durability, availability, scalability. It has many use cases. It's a very general purpose storage, right? You can use it for many different things, including using it as a place for your static website. Right? You can't run programs, right? You can't use S3 for PHP, Java type of applications, but you can certainly use it for a static website, right? HTML, JavaScript, CSS, that kind of stuff can be hosted on S3. So we'll see this, and through these examples, you'll understand these services better. All right, so let's look at these demonstrations, and then we'll move on to Glacier and other services. All right, so let me sign in here, right? And this might be something that you're not seeing with your account, right? So this is essentially a two-factor, multi-factor authentication that I have turned on my account. You should do the same, and we'll discuss this in one of the upcoming modules. All right. By the way, they've changed the look of the homepage, right? You might have noticed that as well. All right. So I'm going to go into EC2 here, and right now I don't have any volumes, any servers, right? Now let's look at EBS first. So first of all, there's a EBS section. Right? EBS is not a separate service; it's part of EC2. So you have to access this from the EC2 control panel, right? And you can see this section here on the left side, EBS, and there are two items here: volumes and snapshots, right? So first of all, let's create a volume, right? Let's take a look at what an EBS volume looks like, and let me create this. And the first thing you do is select the volume type, right? And we saw in the slides there were three that we looked at. One was a general purpose SSD, the other one was a provisioned IOPS SSD, and then this one magnetic, right? There were three options we talked about, and these two are new options that have recently been made available. These are HDD type, right? HDD type, and the way you have to select these is if you're running things like databases where IOPS is important, right? Input output per second is important, then use solid state, right? And if you're running other types of applications where throughput is more important, right? Throughput is simply the amount of data which is moved, right? So Hadoop, for example, right? Hadoop big data type of use cases need higher throughput, right? So for those types of use cases, you will use HDD type of volumes, right? And of course, magnetic is cold storage, right? So in terms of tiers that we have seen, right? These are tier 0, right? Tier 0, tier 1, and these are tier 2, right? And magnetic can be tier 3, right? So these are the different options available with an EBS volume. All right. Now you can select the size, right? You can select the size of your EBS volume. Remember, you shouldn't have too big a volume because you'll be paying for it, right? So it's pay as you go. The more, the bigger the volume, the more you pay, right? So you don't want to set up something too big. Make sure that it's appropriately sized, and remember that you can always change the size, right? It's easy to scale out when your database expands or you need more storage, right? So normally you can start with something very small. The minimum is 1 GB, right? The minimum is 1 GB. All right. Okay. Now, one more thing to remember is there is a relationship between the size of the EBS volume and the IOPS that you can expect, right? The performance you can expect. So a bigger volume has more input output per second, right? So if you look here, right, with 1 GB, I have 100 IOPS, right? I can expect only 100 IOPS here. But if I were to increase the size to say 100, I get 300 IOPS, right? If I increase the size to say 500, I get 1500 IOPS, right? So there is this relationship. You should be aware of it. And one way of improving the performance of your database, for example, would be simply to have a bigger EBS volume, right? And with general purpose volumes, you get a maximum of 3000 IOPS, right? Maximum of 3000 IOPS, no matter how big the volume is, right? By the way, the largest size the volume can have is 16 terabytes, right? So you can have something like this, this kind of volume as well here. All right. Now the provision IOPS, right? Provision IOPS gives you a maximum of 20,000 IOPS, right? So you can see the difference right there. General purpose only gives you 3,000. It can only give you, well, hang on. Yeah, it can only give you a maximum of 10,000 IOPS, right? Whereas a provision IOPS can give you a maximum of 20,000 IOPS, right? But again, in both places, there's a relationship between the size of the volume and the IOPS that you can expect. All right. Okay. So these are some key aspects here, right? So this is, let's create a general purpose volume, minimum size 1 GB, right? All right. Now the other thing is that the volume is created in a zone, right? It has to be created in a specific zone. Remember, we said EBS volumes are confined to one zone, right? So you need to pick the right zone. For example, if you have a server running in a certain zone, you want to attach this EBS volume to that server, you have to make sure that this volume is created in the same zone as the server, right? Okay, and then there's other options we'll talk about later, right? Encryption, etc. All right, so let's create this EBS volume. All right, okay. Now you can see here it'll be, it's really on demand, so you'll have it right away. There's no waiting here, and any moment now, the state of the volume should become available, right? You can see here it's in an available state, right? It's in an available state. Now, if you were to attach this to a server, it would go into an in-use state, right? Right now, it's in an available state. All right. Now let's also look at this in a different way, right? If I were to create an instance, right? If I were to create an instance, let's say, I prefer Ubuntu. Let me just pick this one and micro instance. And here in this page, in step 4, right, you can see we are adding one volume, right? This is also an EBS volume, right? So EBS volumes can be created as part of your EC2 instance creation as well, right? And you can see here, this is general purpose EBS volume. The size required for this operating system is a minimum of 8 GB, right? So that's why you have 8 GB here, not less, right? You can also add more volumes, by the way, just like you can add more hard disks to a server, right? You can add more volumes to an EC2 instance. You can do it here before the instance is created, or you can do it later as well, right? After the instance is created, you can go and attach a new EBS volume as well, right? Okay. For the moment, let me just keep it to a single volume here. All right. Let me just launch this server, right? Because we'll then see how to attach and detach the server. Let me just attach and detach the volume. I'm sorry. Let me create this EC2 instance here. All right, so our server is coming up, right? Our server is coming up, and if you go back to the volumes page here, you can now see two volumes, right? One is the one that we created directly, right? And then this one on the top is the one that is being created as part of the EC2 launch process, right? It's the same stuff here. All right, and you can see because the one on the top is attached to the server, its state is in use, right? And the other one is currently in an orphaned state, right? It's not really attached, so it's in an available state. All right. Okay. So these are EBS volumes. Now, what you can do is you can take a snapshot, right? Let's say you have this, you have your data in this EBS volume, and what you can do is you can simply go to the actions here and say create snapshot, right? You can create a snapshot in this way. So just give it a name, maybe my snapshot. Right, and that's it. It's very simple, right? So what will happen is in the snapshot section you'll find a new entry here, right? It's already in a completed state because the volume is very small, right? Sometimes the snapshotting can take a long time depending on the size of the EBS volume, right? But you can see here the snapshot has been completed, and this is an exact replica, right? It's an exact replica of your EBS volume. If you had some data, let's say 20 images, 10 video files in that EBS volume, right? All that data would be faithfully replicated in this snapshot, right? And snapshots are stored in S3, right? Although it doesn't say anything here, right? Behind the scenes, the snapshot is stored in S3, right? And remember, S3 has a very high durability, right? 11 nines durability. So the snapshot and the data in the snapshot has a very high durability, right? The risk is that you will accidentally delete this stuff, right? That's the user action is the real risk. But from an AWS perspective, the data is extremely safe, right? Okay, so what we've seen so far is we have seen how to create a volume, right? You can create different types of volumes, different sizes of volumes, and then you can easily create a snapshot of a volume, right? The snapshot is stored safely in S3. All right, now let's say you have a problem, right? You have a problem with this volume. This volume has been there's a hardware failure, or there's some sort of problem, right? You can't really use this volume, right? Maybe we have accidentally deleted this volume, let's say, right? Let me just go ahead and delete this volume. This volume is gone. There's no way to get it back. There's no way to get it back, right? Except if you have a snapshot, right? Except if you have a snapshot. So this snapshot has all the data that was there in that volume, and you can easily recreate that volume, right, using this snapshot. So all you have to do is select the snapshot, and from the actions say create volume, right? You can create a volume here. All right. Okay. Now you can, because the snapshot is in S3, right? The snapshot is available in any zone, right? And therefore, when you create a new volume from the snapshot, you can create a volume in a different zone, right? This is a very key point. From a snapshot, you can create a volume in any zone, and this is very useful actually. For example, if you had to fail over, right? For example, if you had a zonal failure and you wanted to sort of fail over to another zone, right? You would use a snapshot and create your volumes in a different zone outside of the failed zone, right? So I can easily say that, hey, this volume, I want this in 1C, not in 1A, right? So I can just simply come here and I can create a volume in 1C, right? So now you can see this new volume has been created from the snapshot, right? And it's in the zone 1C here, right? Okay, so yeah, so that's how it works, right? What we've seen is from a volume, how do we create a snapshot? From a snapshot, how do we create a volume? Right, and remember the zonal thing, right? Volumes can only be within one zone. However, a snapshot can be used in any zone here. All right. Now suppose you want to attach this volume to the server, right? You have a server here. You have a server here. right? And you want to attach this second volume, right? You want to attach this volume, the one that's available right now, to this server, right? Now, when you can easily do that by going into actions and saying attach volume, right? You can do it this way. Now the problem is the volume is in 1C, right? And the server is in 1A, right? And because the volume is in 1C and the server is in a different zone, you can't really attach this volume, right? So this is the problem that we were talking about in the slides, right? Volume has to be attached to a server in the same zone, right? So let me just, maybe I'll go back to the snapshot and I'll create a new volume, right? I'll create a new volume, this time in 1A, right? This time in 1A, and then we'll see how to attach a volume to the server. So I've created a new volume, right? And now there are 3 volumes, right? There are 3 volumes. This one is the root volume attached to the server already, and this one which is in 1A, one which is in 1C. 1C is really not useful because the server is not in 1C, right? So we'll pick out this one, the one in 1A, and from the actions you can attach this volume to the server that is already running, right? Quite easily, right? And what happens is you have an existing root volume there, right, which has a device name. In Linux, the device names are named like this, right? /dev/sda/dev/stb. These are some naming conventions of the devices, right? So when you're attaching a new volume to the Linux server, you have to give it a name, something like this. So we just go with the default dev SDF, right? Dev SDF. So this way you can attach a volume to a server, right? And now you can see the volume, this one is in use as well, in addition to the root volume which is already attached, right? And if you go back to the instance, right? If you go back to the instance in the detail page, you can see that the instance now has 2 volumes, right? One is the root volume, right? This has the operating system, and then this new one that we have just attached. And by the way, this is the best practice, right? You must have, the best practice says that you must have a root volume and separately a volume where you will store your data, right? So if you have a database on this server, that data of your database should go into this second volume, right? And this is for many reasons. For example, portability, right? You want to migrate from one type of server to the other. You can simply take this volume, detach this volume, and attach it to another server, right? And also, if you want to take a snapshot, you don't have to take a snapshot of the whole thing. Just take a snapshot of your data volume, right? You don't really need a snapshot of your root volume, so you save space that way, right? So other reasons as well for doing this sort of thing. All right. Okay. So I hope this has this has given you some more idea about EBS volumes and EBS snapshots, right? Let me stop here. Let me ask you. Let me see if you have any questions. And after this, I will show you. S3, right? How to use S3 for different types of purposes. All right, so let me answer this question from Greg here. Greg, what you're saying is if snapshots are incremental, right? This is what we saw in one of the slides. Snapshots are incremental, which means if you take a snapshot today and then you take another one tomorrow, right? The one tomorrow will have only the updates in the snapshot, right? That's what we said in that slide. So what you're asking is, does AWS blend them together over time? For example, if you take a daily snapshot, can I consolidate them to weekly to save storage? Yeah, but the way it works is each snapshot to save cost, right? First of all, to save cost, what you can do is you can simply delete the older snapshots, right? Or any of the snapshots, any of these snapshots in the middle, right? So for example, if you're taking a daily snapshot, right, you can delete the older snapshots, or maybe you can delete, or maybe retain only one snapshot per week, right? Something like that is what you can one snapshot per week. So when you delete, right, when you delete a snapshot, you don't lose any data. You don't lose any data, even though it's supposed to be incremental, right? So when you delete a snapshot, they have some mechanism, right? They have a mechanism. We don't know exactly how they do it, but no data is lost when you delete a snapshot, right? So you don't have to consolidate the snapshots, right? You can freely delete the ones that you don't need without losing data, right? So no need for consolidation, uh, uh, right? You can safely delete any snapshot as long as you have a few, right? As long as you have a few for recovery purposes. All right. Ratish, you said taking a snapshot of a large volume could take long, right? How long could this be? Snapshots are generally instantaneous, and that's how we know the exact time from which we can restore if needed. Yeah, it's a good question, right? It's a good question. So I think the way it works is, a snapshot. Uh, First of all, you basically take a snapshot, right? You get the data from the EBS volume. Uh, and then it has to be moved to S3, right? It has to move to S3. So the second part, right, may take a bit of time. So I think you're right in saying that it should be instantaneous. It should be as of a specific time, right? But I'm talking more about the availability, right? So the snapshot is not available to be used for some time, depending on the size of the EBS volume, right? So the second part may take time, and the snapshot may not be available, right? It may not be available right away, uh, even though the data will be snapshotted at a specific instant, I guess, right? Uh, so I think this is how it works, but I'm not 100% sure. Maybe we'll have to look into this a little bit more, right? So, all right, okay. Tony, how does snapshots interact with active databases? Is there a risk of corruption, right, or risk of inconsistency, right? So this is actually a question that applies to any sort of snapshot, even outside of AWS, right? It's the same thing with any sort of snapshot, and the answer is yes, right? Yes, there is. Uh, uh, those risks are there, right? Those risks are there. So what you should do ideally is the best way is ensure there is no data flowing into your EBS volume, right? So what you could do, for example, is maybe you can stop, uh, maybe maybe stop the instance, right? Some people also like to unmount, right? You can also unmount the volume, uh, right? Or some other way in which you can ensure that there's no data uh, uh, going into your EBS volume at the point of snapshotting, right? So these are some precautions you can take, but in general, especially if you take it at a during maintenance window late in the night, it should be fine, right? It should be fine. So my practically I'll share what I've seen, right? I've always had a snapshot without stopping the instance, and I've never faced a problem, right? So the snapshot recover you can basically create your volumes quite easily. I've not faced a corruption or any instances of inconsistent data, right? But that could be my applications, right? The nature of my applications. You might face a problem because it could be different for you, right? So yes, the best practice is to make sure that uh, it's kind of cold, right? There aren't any processes running. There's no data going into that EBS volume, and that's how you should take a snapshot. All right. Okay. So this was EBS, right? Now let me show you S3 a little bit, right? Let me show you S3 a little bit, um, and I'm going to show you a few things, right? I'm going to show you a few things with S3 because it's a very general purpose storage service. You can use it for many different purposes, right? First, let's look at how to use S3 for a website, right? You can actually create a website on S3, but only a static website, right? It has to be a static website, which means HTML files are fine, CSS files, images, JavaScript is fine because JavaScript runs on the client, not on the server, right? So you can use it for a static website. You cannot use it for PHP, Java type of web applications, right? So we'll see this example. Then I'm going to show you another example of S3 where we use it more as a storage service for storing database backups and so on, right? Okay, let's look at one example of this website example. All right, by the way, before that, let me just make sure that I clean up here, right? I just wanted to show you guys how to make sure that you delete all these things, right? It's a good practice. Once you finish your work, make sure that you remove everything so that your costs are, you're not surprised by the cost, right? So I'm going to make sure that I delete this instance here. I don't need it anymore. Right, and also I will make sure that I delete any snapshots here. Let me delete the snapshot. And finally, let me also make sure that I delete the EBS volumes here. All right, so these should get deleted, right, as part of the instance deletion. All right, maybe I'll come back to this. So let's go to S3, right? Let's go to S3. And S3 is the first service under storage, right? It's the first service under storage. So let me just click here and show you one example of S3, and then maybe we'll go for a break. All right, I've got a lot of buckets here, but let me create a new bucket, right? Let me create a new bucket here, and we're going to use this bucket for our website, let's say, right? So the first thing you need to know, right, about S3 is the bucket name has to be unique, right? And not just unique within your account, it has to be unique across all users of S3, right? This might surprise you, right? It's not very intuitive, but the reality is that the S3 bucket is unique across all users of S3 around the world, right? So it has to be, for example, if I were to do something like this, right, Edureka, and if I were to try to create this bucket, it says the bucket name is not available, right? Bucket namespace is shared by all users. Please select a different name and try again, right? So this is the first thing. The bucket name has to be absolutely unique. It's like a DNS name, right? It's like a domain name, yourcompany.com. You can only use it if somebody else has not already reserved it, right? So bucket names are the same. All right. The second thing you need to know, right? The second thing you need to know is that if you're using this bucket as a source, as a store for your website, right? Then the name of your bucket should match the domain name, right? It should match the domain name. For example, let's say let's say we call it our website, right? Let's say this is this domain is just a domain I'm using for demo purposes. It's one of the domains I happen to own, right? But there's no significance to this, right? But let's say you have a website which has this domain name, right? Our website.paisapro.com. So this the bucket name has to match the domain name, right? So it's the second thing you need to know. All right, so bucket name has to be unique and the name should match the website DNS name. All right, so this is our bucket, right? This is our bucket. Let me click on this here. Right now, the bucket is empty, right? The bucket is empty. You can create files in this, you can create folders in this. For example, right, for a typical website, maybe you need a folder called CSS, right? Maybe you need a folder called images, maybe a folder called JavaScript, right? Stuff like this. This is how a static website normally looks like. And then, of course, you can add various types of files in this bucket under various folders, right? Okay, now what I'm going to do is I'll create a simple web page, right? Let's say, right, let me create a simple web page, our website dot HTML, right? Just a HTML file. And here I'm going to add one or two HTML tags here. So let's say hello world, right? And then another line here saying from an S3 bucket, right? So this is our home page. Let's say this is our home page, and we will sort of use this as a home page for our website, right? So what you have to do is you can upload this this HTML page by clicking on the upload button here, and let me just find this file here. Yeah, so this is the file that I just created, right? So I'm going to select this, and I will upload this HTML file on the S3 into the S3 bucket here, right? And that's done. And you can see this is our HTML file saved in the bucket. All right. Okay. So far, so good. Now, remember we said that S3 content is accessible over HTTP, right? And if you look at the properties of this HTML file, you can see right here that there's a URL, right? There's a URL for this HTML file, right? So if I click this URL, I should see the HTML page, right? Let me do that. Let me go ahead and do that. And what happens is there's some sort of access denied problem that we see, right? Let me share this with you. You can give this a try from your browser, right? And all right, yeah, Paul, I think yes, we'll go for a break in just a couple of minutes. Yeah, so let me just send you this, right? Let me send you this, and what we're seeing here is there's a permissions problem, right? There's a permissions problem, and remember in the slides we said S3 is a service which is not just storage, right? It has a very granular, very powerful permissioning mechanism built on top of it, right? So that you can have secure you can save your content securely in S3, and then very selectively grant permissions for people to access this content. All right. Okay. So yeah, let's take a break. Let's take a break here. Right. We have seen a bit of S3. Let's take a break. Feel free to enter your questions. All right. So it's 10:19 IST. Let's come back maybe 6 minutes. Right. So let's come back at 10:25. Right. Approximately 6 minutes. All right. Okay. So see you soon. See you soon. All right, folks. So let's start. I hope you're back. All right. So we were looking at S3, right? And we're looking at how to create a website on S3. And what we've seen so far is how to create a bucket, right? Remember that the bucket name has to match the name of your website, and also the bucket name has to be unique, right? Even if you're not using it as a website. All right. And we also seen how to create folders and how to upload files into the S3 bucket, right? And remember, each object can be accessed using a URL, right? This is how S3 is different from EBS, right? EBS content can only be accessed from your operating system, just like a hard disk, whereas S3 can be accessed over the HTTP protocol, right? But what we've seen is we've run into a problem when we try to access this HTML file here, because we now know, right, that S3 has a permission system, right? And by default, everything is blocked, right? As with any firewalls and other types of security mechanisms, by default, access is denied, right? So if you need to give people access to this HTML website, you need to open up the permissions, right? So we'll see that next. Let's see that next here. So what you can do is to set up the permissions, you can go to the website, to the bucket, I'm sorry, and if you look at the properties of the bucket, right? If you look at the properties of the bucket, there's a section here called permissions, right? Section here called permissions, and there are multiple ways of granting permissions, but I think the best way is what is called bucket policies, right? The stuff that you see on the top is the access control lists. These are simple ways of allowing access. However, a better way is bucket policy, right? Now, the way you create a bucket policy is you create that JSON-like structure here, right? So remember on the slide we saw some JSON policies, right, with those nested brackets, right? So that's what you write here. That's what you write here to grant permissions to the contents of this bucket. All right. Now you don't have to, you don't have to type this stuff. There is a tool available that can create that policy for you, right? So on the left side at the bottom, you can see there's a policy generator tool here, right? So let me click on this, and this opens up this page here. And what you do is you create a policy in this fashion. So we'll say we're creating a S3 bucket policy, right? And we want to allow access to anybody, right? So this is going to be a public website. So anybody, which means the principal is set to star, right? So anybody can access this website. However, they can only access certain actions, right? So the S3 permissioning mechanism is very granular, right? You can control access to different actions, to different files within the bucket, and here, because it's a public website, right? We have a very simple action that needs to be allowed, and that action is called get object, right? So to view the website, the website visitors only need a get object permission, right? They don't need other stuff like creating permissions to create a bucket, to delete an object, right? To upload an object. They don't need any of those permissions. They only need get object permissions, right? So this becomes the single action that needs to be allowed. And then we also need to specify what they have access to, right? So here we have to specify the bucket name, and here we need, there's a notation. There's a notation called Amazon resource name, right? So the way this is done is you say ARN, which is Amazon resource name, colon AWS colon S3, right? And then 3 colons followed by the name of the bucket, right? So the name of the bucket, let me just go back and check here. It's our website.paisaflow.com. So this becomes our website.paisaflow.com, right? So this is the bucket. And then within this, we say / and star, which means all the contents, all the files within this bucket is allowed, right? So we're granting permissions to all the content within this bucket, right? So when you do this, right, and you generate a policy, this is what you get, right? You can see here we are basically allowing access to anybody and everybody, right? Permissions to do get object, right? This is the only action, and the resource that we are granting this permission for is this bucket and all the content within this bucket, right? So this is how the policy is created. Once you become familiar with this, you can start writing this yourself, right, directly, or maybe you can edit this directly in the JSON format, right? Okay, now I'm going to copy this policy and I will paste it in the bucket policy editor of this bucket, right? And let me just save this, and that's it, right? So now we have made this bucket into an open bucket. Anybody can view the contents, right? Now, if you were to go back to this URL, right, you should hopefully see the home page. Right, this is the website. This is the HTML page we had uploaded. You can try this from your browser, right? You should see this particular page now. All right, okay, but it's not yet a website, right? This bucket is not yet a full website. What we need to do is we need certain other configurations to be made. So if you go back to the properties of the bucket, right, look for this section here called static website hosting, and here we are essentially enabling. You select enable website hosting. This is, some of you who are familiar with web servers will know this looks like a web server configuration, right? Essentially, in web servers, we specify the index document. This is the home page, right? So, so we specify this page as our index. If you like, you can upload a 404 HTML file. This is the file that is shown if a certain page is requested but is not really available, right? So these are standard web server type of settings, right? So that's it. You essentially enable website hosting, specify the index and the error documents, and click on save. Right. So when you do this, right, you'll find that there's an endpoint that is available here. This is the endpoint to your website, and you can click on this to view your website. And here on this homepage, you may have different links and menus, right? And if you click on those links and menus, you'll be taken to other parts of this website, which is, those files will also have to be uploaded in this bucket, right? So this becomes a full-fledged website, right? You can have CSS, you can have images, you can have JavaScript, all the things that are possible in a static website is stuff that you can upload in this bucket, right? And you can see how simple it is, and by the way, it's extremely cheap, right? So if you were to create a website on S3, and if you were to compare the cost of doing the same thing on a EC2 instance, right, or maybe some sort of web host that is available, right, you'll find that the cost of hosting a website on S3 is close to zero, right? Your cost will be close to zero because S3 is very, very cheap, right? So don't have static content on EC2, because compute services like EC2 are way, way more expensive than storage services like S3, right? So this is the key point here. All right. Okay. So now we have a website, right? We have a website. Now, one more thing is that we don't want our users to look at this sort of URL, right? We want a proper domain name. So we need to use a DNS service, right? We need to use a DNS service. We've seen this Route 53 service, right, last time as well, where we pointed our domain name to our EC2 instance, right? But here we want to point our domain name to our S3 bucket, right? So that our website works end to end. So this is the hosted zone, right? We'll talk more about this. How do we set this up? But here at the moment, I'm just going to create a new record set, and we have to use the same domain name. This is the same as the bucket, right? So make sure the two are matching, and here we simply say yes to alias, and from the alias target list, we should be able to select our S3 bucket, right? So just give this a moment, and here we are, right? So this is our S3 bucket, and we simply select this as the target, right? And with this record set, the domain pointing to the S3 bucket, we will have a proper URL for our website, something like this. Right, so you can see here, this is our homepage being displayed. Let me share this with you, and you can try this in your browser. All right, so here's the domain name, right? You can try this on your browser. You should see this page. Sometimes you may not see it, right? Some people may not see it because DNS records can take some time to propagate, right? But most of you should see this homepage. right? So this completes our demonstration of how to create a static website on S3, right? And this is by no means the only thing you can do with S3, right? S3 is extremely general purpose. You can use it for many different use cases, right? And let me show you one more demonstration because I think this demonstration highlights some other aspects of S3 that we saw in the slides, right? What I'm going to do is I'm going to use S3 as a store of our database backups, right? So for example, so what we can do, for example, is let me create another bucket, right? Let me create another bucket here. Let me call it my buckets, right? And just to make it unique, I'm going to give it I'm going to add a date here, 19th November. Rather, let me call it my backup. Right, so this is another bucket that we are creating, and in this bucket we want to store our backup files. Let's say database backups and stuff like that, right? So you could have say folders like Oracle DBs, Oracle DB backups. Maybe you have MySQL as well, right? Maybe you want to store some log files. So you can create different types of folders within this bucket. Right, and now we want to upload some content here. We want to upload some of these backup files, right? So what we can do is let me create a backup file here first. Right, so just a dummy backup file. So a dummy backup file. Right, so let's say we have this file and we want to sort of upload this into our S3 bucket. Right, so you can upload this directly. You can basically go to upload and you can upload from here, right? The way we had uploaded the HTML file, right? You can always do that. However, backups are something that you normally want to upload via some script, right? Because you can't go every night and upload something in your bucket. So you need some kind of scripting mechanism, and this brings me to another aspect, right? Another interface of AWS, which is called the command line interface, right? So what you can do is instead of using the web console, you can write a command something like this: AWS S3, and you can move this dummy backup file. Yeah, my apologies for the typos, but this is the backup file, and we want to move this into, let's say, this bucket here called my backups 19 November, right? And you can also give it a key. You can say backup 19 November, something like that. Maybe 1040 is the timestamp. Something like that, right? So basically what we're doing is we're running a command, right? We're running a command here. We're not uploading a file using the web console. We're running a command here. And these commands are part of what is called the AWS CLI, command line interface, right? And it's a whole bunch of commands. And these are basically commands that you would normally execute via the web console, right? So if you can do an upload, the same command is available via in the CLI. Right? If you want to delete a folder, the same command will be available in the CLI. Right? So the CLI is just a different interface. It's very similar to the web console. It's just a different interface, just a different way of accessing and interacting with AWS. Right? So you would basically use this sort of command to upload your file, and of course you want this to be automated. So you include this command in a script, right? So it could be a shell script, a Perl script, something like that. And then you can also schedule that script in the cron tab or the Windows scheduler, right? So that's how you would do something like this. Right? In fact, let me show this to you. Let me try and upload this. Let's see what happens. All right. So here there's essentially a permissions problem. The access key ID provided does not exist. So what's happening here is just because you use the CLI doesn't mean that you have open access to the bucket, right? You still need permissions. The reason we are able to upload stuff in the bucket here is because we have logged in, right? You saw that I logged in with my username and password and also a second factor, right? So there's a good security in the web console. Similarly, there's a security mechanism for the command line interface as well, right? So what I'm going to do is I'm going to quickly show you something, right? We'll discuss this in detail later, but basically what you do is you have to create a user for the command line commands using identity and access management, right? This is a major management tool, and you can create users, groups of users, and permissions using the IAM console, right? So what I'm going to do here is really quickly, I'm going to create a user. Let's say this is a backup script user, right? It's just a user whose only job is to create a backup script, right? And this user needs CLI access, right? So that's why we choose this option here, not the web console. And all right, and let me just create this user first, and then we assign some permissions to this user. All right, now this user has an access key and also a secret access key, right? So this is essentially the username and password, but for the CLI, right? So we need to set this user up in the CLI, and then we'll be able to upload our file, right? So the way this is done is first you need to install the CLI, right? You can do that. I'll explain that to you later. But basically, once the tool is installed, you can configure the CLI by running the AWS configure command, right? And in this, when you run the configure command, the first thing you configure is the access key ID and then the secret access key. This is essentially like a password, a username, and a password. Right? Make sure the secret access key is copied fully, right? So we are setting up the access key ID, the secret access key, and then some other configuration items, right? Once this is done, you can run a command like this one where you can copy the file. Now, before that, this user also needs some permissions, right? We haven't given this user permissions. So what I'm going to do is I will click on this user and I will add some permissions, right? And what we need to do is give it some S3 access, right? So right now I'm going to give it S3 full access, right? So there are many different permissions. You can also give it at a very granular level, but right now we'll give it at a coarse level. We are granting full S3 access to this user just to keep things simple. All right, so now this user has S3 full access, right? And now when we run this command, we can copy this file from this local machine, my computer, into the S3 bucket, right? You can see the command has executed successfully, right? Okay, now if you go back to the this bucket here, we should see our backup file in this bucket now. But you can see this is the backup file we just uploaded using the CLI. All right. So what you'll have to do is to do this regularly, you'll have to include this type of command in a script, in a shell script, Perl script, something like that, and then schedule it in a cron tab or a Windows scheduler so that everything is moved into the S3 bucket automatically, right? Every night, every week, every month, whatever schedule you decide. Right? Okay. Now this is one thing, right? There's something which is very good about the solution. Let me show that to you next. Now let's say you have this bucket here, which is used for backing up your storage, right? Now what you can do is, if you look at the properties of this bucket, there's something called life cycle. Right? There's something called life cycle, and you need versioning to be turned on. Let me just turn this on here. Versioning basically allows you to keep multiple versions of the same object, right? It's good for protection against accidental deletes and accidental overwrites. So So what you can do is you can create a lifecycle rule where you say something like this. What you say is 30 days after an object comes into the bucket, move it into infrequent access, right? So we're basically moving the object automatically, right? 30 days after that object is created in the bucket into a cheaper storage class, right? And then we can also see something like this, where we say 60 days later, all this is configurable, right? 60 days later, move it to Glacier, which is even cheaper, right? And then finally, you can expire. You can basically remove this after maybe 1 year, right? Maybe after 1 year, you want to remove this particular item, right? And this is a life cycle which applies to each object independently, right? So each object has its own life cycle, and you can create a rule like this, and that's it, right? Once you have a rule, all the objects in this backup bucket will be moved into cheaper storage classes, um, as per their own life cycle, right? So with this one simple rule, right, you have solved that major problem, right? You remember in that slide, 95% of the data is in the wrong storage, right? And with this one simple rule, you have solved that major problem with storage costs, right? Okay, so let me stop here. We've basically seen two examples of S3. One where we used it as a place for a static website, right? And two, we have seen that S3 can be used to store our backup files, right? And we can also create a lifecycle rule where we can move things to cheaper storage classes automatically. All right. Okay, so I think that's a lot of stuff we have covered. Right, and these two services are really the most important ones, right? EBS and S3 are really, really important. Let's make sure that you understand this, and let's discuss this. All right. Okay. So let me just answer these questions, and Greg, maybe I'll show some of this stuff to you once again. All right. Okay. So Tony, can you auto sync an S3 bucket with a local directory on my computer? Yes, you can. You can. Right. So it's a good question, and I can see where you're coming from, right? Because sometimes we need the two places to be in sync rather than moving things or copying things one by one, right? So what you do is if you look at the CLI reference, right, and going back to the second question from Ratish is, where can I see the, is there a documentation? Also to Greg's question, right, is there a place where all these steps are there? So what you do is just search for AWS CLI, right, and you'll be taken to this page here, and by the way, the installation is very simple, right? So on Windows, you have this MSI file, right? The installer file available, and you simply download this and run it and go through the steps. On Windows, it's very simple usually, right? And then on Mac and Linux, it's a single command. This one, pip install AWS CLI. Pip is a Python installer, and just run this one command, and you'll have the CLI installed on your machine. Right? And once you install this, you need to configure, right? You need to configure, which is the way I showed you. You have to run this command, AWS configure, and then supply the credentials, right? Using these credentials are created using IAM. And we'll talk about, by the way, Greg, we'll talk about IAM in detail in one of the upcoming modules, right? So you have to have a user. The credentials have to be configured before you use the CLI. Now, the CLI commands are available in the CLI reference here, right? So just click on this reference document here, and all the commands are listed by service, right? So there are many services. So for example, you have EC2, you have S3, of course, right? You have S3 here, right? S3 has two API, by the way. There's one here, one called plain S3, and the other one is called S3 API. So this one has high-level commands like move and copy, and S3 API has more low-level commands. So this is more powerful, right? And S3 is just the most commonly used commands, right? Now within this, you'll find there's a command called sync. There's a command called sync here, right? So you can use this command to keep the folders in sync. Let me see. Let me just go to this link here, right, which covers the sync command, and you can see the documentation on this command. And also, it usually shows, gives you an example as well. So here's an example, right? So just write AWS S3 sync. A dot simply means the current directory, right, and then the bucket name, right? So it will synchronize your current folder with the bucket, right? Okay, let me just type this here, and just as an example, you can have this command. Let me just write here local directory, right? Local directory, and then space, and then the bucket that you want to synchronize with. All right, Ratish, can you show how do we access the CLI again? Is there a CLI reference manual? So the answer to that is the reference manual is available. Right, so this is the reference manual. It has complete information, including documentation and examples. Right, and the installation is something like this on Linux, and right. So this is the installation, and then usually you need to configure it as well, right? Installation on Linux, Mac is like this, and you also need to configure. You need to configure the CLI. So what you do there is you say something like AWS configure. Right? On Windows, it's an MSI file that you download. After that, it should be the same. Right? It should be the same as on a Mac or Linux. All right, and the user has to be created on IAM. Right, and IAM is something we'll discuss in detail. All right. Okay. And Greg, do you have a document that lists all the steps? Let me maybe I'll show this to you once again. Right. Maybe I'll show this to you once again. And also, we'll be seeing this again and again, right, in many demonstrations and examples. So we'll cover this again, right? So I think you'll find this easier the next time we see this. All right. Okay. Any other questions? All right. So this question is a good one as well, right, Ratish? What you're asking is how do we use AWS documentation properly, right? Is there a good starting point, right? How do we sort of navigate the documentation for various things? So at a high level, let me just explain a few important things, right? So what you can do is just go to aws.amazon.com, right? And this is where you start, right? This is where you start, and in the menu you can look at the products, right? You can look at the products menu, and then you'll find the same categories that you find in your console, right? Compute, storage, databases, etc. Within each category, you have the individual services, and just click on the individual service that you're interested in, right, or the product that you're interested in. And here you can basically look at 2 or 3 resources. One is this is the overview, right? The home page is the overview. Look at product details. And product details is a very good page. In general, it quickly brings you up to speed with what the product does, how it can help you, right? It has things like information about features, etc. right? The next resource I would recommend is the getting started resource, right? So here you can quickly get started with that service, right? Very quickly you can get started with this service, right? And for more details, more the finer aspects of the service, look at FAQs, right? Look at FAQs. So this is low-level information, frequently asked questions, very good additional information, right? In addition to the product details page that you'll find here. Right, so this is how you can approach this. This is of course just one way, right? You can also do it differently. For example, one more approach I can suggest is just do a Google, right? If you need to do something, let's say install WordPress on AWS, right? Just do a Google for that, and you'll find lots of resources. So, for example, install WordPress on EC2, right? And let's say Windows. Right, so you'll find a tutorial either from AWS or from somewhere else as well. Right? Okay, let me just summarize this here for you. So first step is look for product details page. Example, EC2 product details, right? Next is the getting started page for the product, right? And then FAQs is great as well. FAQs is very, very good, right? Highly recommended, especially once you become a little familiar, right? For things like studying for the exam as well. A lot of questions come from the FAQs. So a little more advanced, it's good for advanced questions, right? And in general, right? In general, Google is good as well, right? Example, how do I set up WordPress on AWS EC2? All right. Okay. So I think we have, we're running a little bit short of time. We have about half an hour. So I want to show you Glacier as well. But before that, let me answer Greg's question here. Let me show this to you once again, right? And I'll summarize it here as well. So what we were talking about is S3 and how do we use it for backing up our database backups, other types of archival files, right? So I think you would know how to create a bucket, how to create folders, right? That part is simple enough. On the CLI side, right? On the CLI side, what you need to know is, first of all, you need to install the CLI, right? It's a sort of a small toolkit which has to be installed on your client, right? It can also be installed on a server, by the way, right? You can install it anywhere from where you want to sort of interact with S3, right? So it could be on your computer, on your own laptop, or it could be another server where you have your databases running, because from there you may want to transfer your files into S3, right? So the toolkit can be installed anywhere. In Linux and Mac, you install it this way, just a single command, and this is sufficient to install the CLI toolkit. On Windows, you have to download an MSI file and then install it, right? Okay. Next step is to configure the CLI, right? And by configuration, what we really mean is, who's the user, right? Who's the user that is going to interact with S3, and what region are we talking about? And some other details, right? But the main thing is the user, right? So what you do is you say AWS configure to configure the CLI, right? And here you need to specify the access key ID and the secret access key, right? This is a username password for the CLI, right? It's a username password for the CLI. You can have, for the same user, credentials for the web console separately, right? So one user can have different sets of credentials for different interfaces, right? And the CLI is one interface to AWS, right? Okay. Now the question is, where do I get this access key ID and the secret access key, right? So what you do is, there is a service called Identity and Access Management, right? It's a very important service. You have to use it, right? If you are once you move into serious use of AWS, right, it has to be used because this is how you control access, right? Who are the users? What can they do? What can they not do? Right? Those kinds of things can be controlled from here, right? And what you do normally is you can create a user, right? You can create any user. This could be an individual person, right? It could be a real person, or you can create a user for a script, for a machine, right? So basically, you create a user using this button here, right? And when you create a user, you can specify what type of access you want to give. If you want to give, if you say programmatic access, you're essentially creating the access key ID and the secret, right, which is used by the CLI. Or if this is a real person who will only use the web console, you can use this option, right? In this case, there'll be a password. In the first case, there will be a key ID and a secret that will be generated, right? So you create a user. Let me create another one here. Let's say backup 2, right? And what you do is you can assign some permissions. For example, you can say we want to give this user full S3 access, right? So the user can do anything in S3. This is powerful stuff, right? Normally you wouldn't do this. You'll give something less, at a lower level. But for now, let's say we want to give this permission. And when you create this user, right, you will be able to access the access key and the secret access key here, right? So this is the stuff that you set up here, right? This is the stuff that you set up here, and once you've configured this CLI, you can run those commands, right? You can run those commands. So what you need is just to summarize, right? Just to summarize, what you need here is download the CLI, right? And using download and install, right? Download and install the CLI. For Windows, it's an MSI file, right? It's an MSI file for Windows. To configure, right? Configure the CLI using AWS configure, and mainly you need to set up the access key and secret, right? So for this, what you need is before this, what you need is let me say 1.5 here, right? What you need is create an IAM user, right? Grant permissions to generate the access key ID and secret, right? And then in the third step, you use the access key ID and secret to set up the user with the CLI, right? And then you can execute the CLI commands, right? And the CLI commands are available in the reference, right? In the reference that's mentioned on the top, right? So with S3, you have commands like copy, move, sync. Those commands are simple enough. All right. Okay. And Greg, what you're saying on the webinar panel is you're hoping for a document mainly, right? Well, again, it depends on the use case or on the specific objective you have in mind, right? And then you can just do a Google or look for AWS, look for stuff in the AWS documentation, the getting started guides. By the way, there's lots of if you take any product, right? Let's say if you take S3 here, there's developer documentation as well, right? So let me see if I can find that here. Yeah, so you can go to the documentation section here, and you'll find developer guide, right? Developer guide, API reference, console guide. So here in these guides, you'll find lots of information, right? But usually it's faster to, I think, just do a Google around what you're trying to achieve, right? And I'm sure you'll find the steps. All right, so let me just paste this. Maybe this is a good starting point for you in response to this question. All right, okay. So let me show you one more thing, right? I want to show you Glacier. which is a third service, right? It's also an independent service, and it's also a part of S3 in that it's a storage class within S3 as well, right? So let's just talk about this a little bit, and then I'll show you how to use Glacier as well. All right, so it's a low cost, right? It's equivalent to a tape drive actually, right? And remember that pyramid, right? Glacier is right at the bottom, the tier 3 service. It's low cost, and it's meant to store vast amounts of data, which is for long-term storage, right? And archival, right? Archival is the right word when it comes to Glacier. In fact, when you upload something in Glacier, those things are called archives rather than objects or files, right? So, right, but you can store, just like S3, you can store anything. You can store anything in Glacier, right? And a single archive can be larger than an S3 object. So with S3, you have a limit of 5 terabytes. With Glacier, you have a limit which is much larger, which is 40 terabytes. Otherwise, there are no limits, right? You can upload any number of archives into Glacier. All right, let me show this to you, right? Let me show this to you really quickly, and then we can discuss this more. So if you go back to the home page, right, in the storage and content delivery section, you can find Glacier as a separate service, right? So it's an independent service as well. You can upload content, your archives into Glacier directly, right? Or you can go via S3, right? So you upload into S3, and then you can use the lifecycle rules to move things into Glacier, right? So you can do it both ways. And now let's look at Glacier here. So the thing about this this service is that you know there is no availability, right? There's no availability. It's durable and very low cost. However, when you upload something or when you download something from Glacier, you can expect to wait for many hours, right? When you want to download something, it normally takes at least 4 hours. It takes 4 hours, right? And think about this. It's you know, let's say you're a bank, right? And your regulators demand that you keep your data for many years, maybe 7 years, right? And then someone, maybe there's some tax investigation, maybe there's some regulatory investigation, maybe there's some police investigation, and they come to the bank. The authorities come to the bank and say, look, we need a certain amount of information from 1 year back, 2 years back, 3 years back, right? And normally, you know, such requests are not very urgent, right? They will easily give you, they'll normally give you, say, a 1 month notice, right? Or maybe a 2 week notice. They'll say, look, we you know, just give us the data in 2 weeks, right? That's how normally it would work. So you can store that kind of data in Glacier, and you can download the stuff. You have to wait for 4 hours, right? And you can easily meet those requirements from those authorities, right? So that's the kind of picture. I'm trying to give you a picture of how you would use Glacier, right? Normally, you would use it for stuff where you have time, right? Where you have enough time to get the files back from Glacier. All right. So what you do is you normally would create a vault, right? You create a vault, basically just give it a name and select your region. And what you do also is you create some notifications. Right? You create some notifications. And the reason you create notifications is that you can't interact with Glacier. It's not interactive, right? So you say, look, I want to download this file, and then that's it, right? It says, fine, we have received your request, right? And then there will be a notification which comes to you once the file is available for download, right? So because everything is slow, right? Everything is asynchronous. You need to set up some notifications so that you get notified when things are available for use, right? So this is how you created. I have already created some vaults here. Let me show you one of these. So you can see here, this is my backup. This is a vault here, and I have some notifications set up. So whenever there's a archive retrieval job completion, I get notified. So archive retrieval is what you do when you want to download something from Glacier, right? So basically, you create a vault. You can create many different vaults, and you set up some notifications so that you become aware of availability of certain things on Glacier. Right. So broadly, this is how it works. Now you will notice, right, in this web console, there's no way to upload or download. There's no way to upload or download and from the web console, right? So the only way to interact with Glacier is via the command line interface. It's via the command line interface, or you can go via the S3 route, right? So you upload in S3 and then use lifecycle. Right? That's one way. But if you want to go directly to Glacier, then you have to use the command line interface. Right. So we're back to this page here, and let me show you some of the Glacier commands here. All right. So we're going to run some Glacier commands, right? So let's say you can run something like this. Maybe you can say help here. By the way, you can use the help option to look at some information about the commands available, or you can go back to the CLI reference, right? So if you go back to AWS CLI for Glacier, you can look at the various commands available here, right? So for example, there's a command for upload archive. Right? This is how you can send stuff into a Glacier vault. Right? So this is upload archive. You can see an example here. Right? Let me run this command and let's see what happens. So what you say is, you say AWS Glacier, and the command is, let me look here, AWS Glacier upload archive, right? You have to specify the account ID. This is the 12-digit account number, 12-digit AWS account number that you have, right? And there's a shorthand for it. You can just say hyphen, and that simply means your own AWS account, right? But this is a mandatory option in this command. All right, and then you can say vault name. You can say vault name, right? And we'll use this vault here, maybe my backup. So let me just say my backup here. Right, my backup is the vault name, and then you use the body option to specify which file you want to upload into Glacier. Right, so right, let me see if there's a file here. Let me just use one of these files here to upload. Right, let me just upload this file here. Right, so basically there's a command called upload archive, and you specify some options, account, vault name, and then in the body option you specify which file you want to upload into Glacier. Right, so this is how it works. Now when you run this command, right, you see there's an access denied exception because the user we are using, the IAM user we are using, does not have the permissions. Right, does not have the permissions because the user only has S3 permissions. So what you could do is you can easily go here, and for this user, right, this was our user, and here we'll just add one more permission, maybe give this user Glacier access as well. Right, so the same user has now S3 access and Glacier access as well. Right. Okay. Now, once the user has permissions, we can now run this command once again, and that's a little odd, right? Because this user has the permissions for Glacier, but maybe let me try this again. Maybe there's a little bit of a lag in setting the permissions. Let's see. All right, yeah. So now you can see the upload archive command has worked, right? And in response, you see the archive ID. This is the unique identifier of that particular file, which has been loaded on Glacier, and you can use this archive ID to download this file later, right? So this is how it works. So this is an example of a command for uploading. For downloading this, there's a different command, right? And for example, if you look at the Glacier command set here in the CLI reference, there's something called initiate job, right? There's something called initiate job. So you initiate the archive retrieval job, right? It doesn't get done immediately. You just initiate the job, and then a few hours later, you get a notification saying your file is available for download, right? And then you initiate another command for downloading the file, which is get job output, right? So first you initiate a job, and then you run get job output, right? So this is how you interact with Glacier if you want to do it directly, right? Or you use the S3 lifecycle mechanism. All right. Okay. Let me stop here. Let's see if you have any questions, and then if you have time, we'll look at storage gateway and Snowball. All right, and you know, the CLI commands that you see here, right? These are not they're not Linux specific, right? So the same commands can be run on Windows as well, right? So these are not really Linux commands, all right? But the setup is different. So the CLI, the installation is a little bit different. Rather, only the installation is different, right? After that, all the steps should be the same, whether you're on a Windows client or a Mac or Linux client. All right. Any questions on Glacier? Right. Remember, it's very important because of the cost. Right. For long-term storage, it's a tier 3 service, right, and very useful for long-term archival. Can make a big difference in your cost structure for your company, right? So it's a very important service. All right. Okay. Okay, folks, so I think we have about 10 minutes here. Let me just talk a little bit about the other, let me just talk about other services quickly, right? One is Storage Gateway, and then the other one is Snowball. Okay, so Storage Gateway is more for hybrid cloud, right? Where you have your existing, where you have applications running in your local data centers, and then you want to extend that, extend some of the storage to the cloud, right? Maybe for scalability purposes, maybe for durability purposes, maybe to lower cost, right? Maybe as a DR. So these are some ways in which you can do a hybrid, right? Get the best of both worlds. So what happens is you have a storage, you have an appliance, right? It's a software appliance which sits on one of your servers in the local server, right? And this appliance talks to the AWS backend services like S3 and Glacier, where it will store your data, right? And this storage gateway has many different, it has, this is how it talks, right? So basically, there's a local appliance in your server room or data center, and over the internet, right, it talks to a gateway on the AWS side, and then the gateway talks to these services, right? This is how it works, and it can be used for many different uses, maybe as a disaster recovery option, right? Maybe just for backup purposes. You can use it for migration, right? Sometimes during migration, it's important that the data is copied in a certain time frame, right? So storage gateways in certain cases can be a good option because it can do things like mirroring, right? And also it can be used for expanding, right? For scalability purposes, temporary or permanent, you can use the storage gateway. All right. Now this is the main thing, right? So there are different configurations for the storage gateway. One is gateway cached volumes, stored volumes, and then the virtual tape library, right? So what happens here is in the first option, cached volumes, you have the data stored on AWS However, some of the data, the frequently accessed data, is cached locally. It's cached locally. This one, the second option, is different in that you want all the data to be available locally, and only the snapshots, right? The snapshots and the backups go into AWS, right? So these are different use cases. You have to configure storage gateway based on what you need. And then thirdly, there's an option for what is called the virtual tape library, and you can basically store your instead of using the traditional tape mechanism, you can store your backup files, archive files in Glacier, right? And that's the option that you can use for those kinds of needs, right? And what you need to know is the storage gateway works over the ICE protocol. Right? It works over the ICE protocol, so you don't have to make changes on your site, right? You just plug in this storage gateway and over the same protocols that you've been using, right? The ICE protocols that you've been using with your existing storage devices, right? You can just plug in this solution, and you suddenly have storage available on the cloud, right? So that's how it basically works here. All right. Okay. Now, a quick word about Snowball as well. Snowball is this kind of device, right? It's a very sturdy physical hardware which is shipped, right? It's couriered between AWS and your corporate data center, right? And this is used when it basically you can plug this into your servers, copy data quickly. You can also copy data in parallel so that the data moves into the device fast, and then you can ship it. You can ship it to AWS, where they will download the data into S3, Glacier, etc. Right, and it can carry a lot of data, and it's tamper-proof. It has encryption. The encryption keys are obviously not shipped with the device, right? So they're not on the device. So even if someone gets a hold of this device, there's no way they can access the contents, right? So this is a very interesting product, good for certain use cases where you need to move the data into the cloud quickly, right? So if you have too much data and it's taking too much time to upload over the network, right? Or you don't want to have contention in your networks, right? You don't want to disrupt the existing use of those networks, right? Network costs may be high as well. So those are the use cases where Snowball makes sense. All right. Okay. So yeah. Let me just stop here. We have about 5 minutes for any questions on what we have seen today. All right, and let me also, tell you one more thing. Tomorrow we'll talk about VPCs, virtual private cloud. And from experience, I can tell you, most people, find that class very difficult, right? So I suggest you do a little bit of reading on VPCs, virtual private clouds. All right. So I think there's a question here. All right, so Ratish, is Glacier and Snowball frequently used? So I'm sure Glacier is used a lot, right? I'm sure Glacier, although I don't have the numbers with me handy, but I'm sure Glacier definitely. Glacier is used very frequently because there's a sound, there's very big economic reason, right? So Glacier is very cheap, right? People can save a lot of their spend, right? They can save a lot of money by using Glacier. So I'm pretty sure this is quite popular, right? And Snowball, I think it'll be used by a smaller number of larger companies, right? Snowball is meant for narrow use cases, right? Where, example, lots of data, need for quick movement of data, right? Stuff like that. So this has narrow use cases, so it will be used less, right? It will be used less. right? And let me also show you the pricing, right? So you can look at S3 pricing and just take a look at how cheap this is. So yeah, so you can see S3 itself is quite cheap, right? It's only 3 cents per GB month, 3 cents per GB month, and then the other storage classes which are inferior in certain aspects, you can see infrequent access is I think less than half, right? It's less than half the cost of S3, and Glacier is only 7/10 of a cent per GB month, right? 7/10 of a cent per GB month. So this is, I think, 1/5 the cost of standard S3, right? So there's a lot of economic benefit if you want to use Glacier. All right, folks. If anything else, please let me know. Feel free to enter your questions after the class as well, right? Um, and of course, you can also contact support if you're stuck with any of these labs or demonstrations while practicing off class. All right. Okay. So I think that's all we have time for, right? We're almost at the end of our allocated time. So let's end the session here, right? And tomorrow we'll discuss VPCs. Please try and read up on that topic. All right. So yeah. So thanks for joining, and have a good night. I'll see you tomorrow.